Uh, Hi guys. So welcome to another session of Bootcamp 2020. So today we're going to see an example application, which is our next step. So before starting, Sergio, do you want to add anything?
Yeah, I just wanted to add, when you are talking about serverless application development, which is infinitely scalable, and you pay as you use the resources, and if you don't use any resources, those are the two benefits of serverless. But the main architecture of a serverless application is basically event driven. And the biggest hurdle of adoption of serverless development is this architecture, in the sense that most people, when they are coming from a monolithic application development, have difficulty in transforming their thinking towards a event-based architecture. So basically, event-based architecture can be it can be without serverless, but if you design it right, serverless applications should be event-based. So therefore, you can have other kinds of event-driven architecture applications which are not serverless, but it's not vice versa. Most serverless applications are built on event-driven architectures. And today, Varis and Humar are going to talk to us about what a event-driven architecture is. Who is
Okay.
going to start?
Thank you, sir. Okay.
Hmm.
Okay. So I'm going to start, and I'm going to share my screen first.
Mhm.
So we are going to see 34 slides, like an example of event-driven application. So in this slide, we are not going to talk about any new service. We're going to see how to use all the previous services that we have learned in an application, which is based on an event-driven architecture. So before actually going through the code, I would actually like to revise a few things. Uh, and for that, I've prepared a slide. So yeah, basically I've covered everything in the previous lectures, but before actually going through this application, it's best to actually revise the uh, important concepts. So, okay, so basically, in this slide, you can see we have two different diagrams. The upper one is the synchronous architecture, which is not event driven. So you can see in this architecture, we have three services. Service A sends a request to service B and then expects a response. Same goes for service B. It sends a request to service C and then expects a response. So the problem is that service A needs to know beforehand the kind of response that it would be expecting from service B. And service B has to know beforehand the kind of request it would be expecting from service A. So therefore, they are tightly coupled with each other. And if I change anything in service A, then it's most likely that I would actually have to change some code in service B. And therefore, the teams that are working on these different services would actually have to coordinate with each other. And these are just two services right now. If there are like 1,000 services, then things get really messy. And another problem is that if service A wants to communicate, like let's say after 1 month I decided to upgrade my application. Now I want my service A to directly communicate with service C. So I cannot do that right now. I would actually have to update my architecture. Well, one way of doing it is to send message to service B, and then service B can send it to service C for us. But there's an extra step. Another way of doing it is to make a connection, separate connection from service A to service C, and then that means we have to change some code in service A, change some code in service C, and this means that whenever you have to add a new service or a new connection, you have to write some code. If I add 100 more services, I might have to make 1,000 more connections, which is like really cumbersome. So these are the problems in synchronous architecture.
I would like to add, Varis here, that this architecture, the synchronous architecture, can also, some people also called it a request-based architecture. Therefore,
Yeah.
basically, why request-based? Because the request comes in, you make a request to another service, and then you make another request, and then there is the C responds to B and B responds to A. Therefore, this architecture is also sometimes called request-based architecture.
Right. Okay. So this was the synchronous or request-based architecture. Now down below over here we have event-driven architecture. So you can see in this architecture, these services are not communicating with each other directly. They don't even know if the other services exist or not. Each and every service is communicating with bus only. And this makes these services decoupled. So if I change anything in service B, I don't really care about that in service A. Like the team that is working on service A don't really care about what's happening in service B because they're not connected in any way. But the question is that how would service A communicate with service B or service C? Well, it communicates through the bus. So it will send an event to the bus, and then service B or service C can actually listen to that event. And this is how the communication happens in an event-driven architecture. Now, the first advantage I told you that they are like not tightly coupled, so they're not dependent on each other. The second advantage is that the teams working on these services can work independently. The third advantage is that if I want 100 more services over here, I can do that without changing anything else, and it is very easy. All I have to do is add 100 more services and connect them to the bus, and that's it. So you can see scalability is very easy in event-driven architecture. So event-driven architecture basically solves some problems that we had in the synchronous architecture. Now this is the second slide. Over here, I'm discussing some more challenges that we have in a synchronous architecture. So let's just say that this is an application, a part of my application, where a customer purchases something. Then a payment service runs. Then payment service sends a request to the update stock. The stock gets updated. And then it generates a tracking order. It confirms the order. It runs two services in parallel. Now, let's say something goes wrong over here. My order did not get confirmed. Then I would actually have to revert my stock back, cancel the tracking order, and revert back the payment. I would actually have to do 3 steps, and there's no way of doing it right now. I can either send a message to this one, and this can send to this one, and here it's kind of a mess. Or the other way is to actually make direct connections over here. But you can see this is quite problematic. But if this was an event-driven architecture, all I had to do was generate an event that the order is not confirmed, and the rest of the services can just retrieve that event and perform the relevant actions. So things get very easy with event-driven architecture. Now, these are some of the advantages that I was talking about. So it decouples the services that we saw over here. There's no connection between the services at all. Debugging is easy, so you can see all the services are isolated, so it's very easy to find a bug. But in a synchronous architecture, because everything is so tightly coupled, it's really hard to find a bug. It is easy to modularize the application so that different teams can work on different services independently. That is what I was talking about over here. So because the services are not connected to each other, the teams don't have to rely on each other. Error handling is also easy, like I showed you over here. So if there was a problem over here, all I have to do is fire an event, and the rest of the services can just listen to that event. If this was a synchronous architecture, it would be very difficult. Even in this small application, it just has 4 services, and the orchestration is easy. So basically, if this was a synchronous architecture, and if I actually had to run 5 more services in parallel after the payment, and then 5 more services for every service after payment, it would be really hard in a synchronous architecture. You can imagine how complex it would get, the communication between them. But it is extremely easy to do in an event-driven architecture. The second point is that if I in a synchronous architecture, if I define it like this, and later if I want to change it, I actually have to change a lot of code. Like if I want to run this before payment, if I want to change the order of the services, it would be really difficult in a synchronous architecture. But in an event-driven architecture, it's not so difficult. So orchestration is easy. Adding more services is not a problem. Like I showed you over here, you can add as many services as you want. It wouldn't be a problem. But here it would be a problem. It would be a big problem. So these are some of the advantages of event-driven systems. Now, in AWS, as we saw before, the service that allows us to create events and then create an event-driven architecture is called EventBridge. But we also saw step functions later on in the course. And then we also discussed that because both of the things do similar stuff, so we also discussed that when to use which. So here's just a summary of that. So EventBridge supports a lot more services than step functions. This is the first point you'll have to consider. Like a lot of services can integrate with EventBridge, but with step functions, I think you can only run Lambda functions and a handful of other services. So if you have a lot of different services, then you will have to use EventBridge. EventBridge is used in the application scope and function. Sorry, are you saying something? Okay. EventBridge is used in the application scope, and step functions are used in much smaller scope within services. So basically, this means that if you have a huge application and you have many different services, then the EventBridge is supposed to sit on top of your application, like in the application scope. It would be managing all the different services. But inside each and every service, you can implement the logic using step functions. So step functions, you can say step function is a smaller version of EventBridge. So step functions are best used inside the services themselves, but the communication between the services can be organized or can be managed using EventBridge. So EventBridge is used on a big scale. EventBridge is usually used in between services and used in places where things have to change frequently. Step functions are usually used to create the workflow of a service which doesn't need to change frequently. So it's easy to change, as I showed you before in this example. It's very easy to change the orchestration using EventBridge. It is not as easy to change in using step functions. So you would usually use step functions in those places where you don't have to change the code frequently, or where you don't have to change the order or orchestration of the workflow frequently. Like for example, like for example, I've given an example over here. The workflow of a payment accepting service would be implemented using a step function. Why? Because you don't usually change the workflow of a payment accepting service, right? You may change it after 10 years, but you don't change it frequently. But how this payment accepting service is connected with the other services in your application may be implemented using EventBridge. Now that payment accepting service, how does that communicate with the other services? That may change often in your application, like with the new versions of your application. So that you can implement using EventBridge. That would be a better way to do it. But these are not definite rules.
I'd just like to add on this slide, if you go back. Yes, thank you. I just wanted to add that, for example, an ordering service. You first try to make a payment, then you see if you have the stock. First you see if you have the stock, then you make the payment, then you send acceptance and so on. This is a lot of small micro, this is a whole ordering microservice with a number of functions. As you mentioned in your slide, it is much better to implement that using step functions. One other reason, which is not mentioned here, is that it is much easier to debug, because all the connected services, all the connected, sorry, not services, all the serverless functions inside a ordering service, a microservice, will be closely knit, and you can easily figure out what is the problem, where did it go wrong, and so on. So therefore, if it's a small microservice which definite steps, it is much easier to debug when you are using step functions.
Okay. Yeah, that is also a very nice point given by Shazia. Okay, so this was the revision for event-driven architecture. Now let's move on to our application that we made. So this is just the the workflow of our application. That how does it work? Just to explain you guys. So it is basically a restaurant booking app. So the restaurant owner can add time slots for booking. So they can basically add time slot for booking, like from 1 p.m. to 2 p.m., 2 p.m. to 3 p.m., and so on. And then the customers can go onto the website, and the customers can request a booking for a particular time slot. And then when a booking is requested by the customer, the owner gets an email. So whenever a customer requests a booking, let's say from 1 to 2 p.m., the owner would get an email and an SMS, and then he can choose to accept or reject the booking. And when the owner either accepts or rejects the booking, the customer receives an email that your booking has been accepted or rejected. So this is the workflow of the application, and it is based on an event-driven architecture. So this is the diagram. So obviously we need Cognito first because we need to sign in and sign up. And then based on the group that user is in, it takes you either to the customer page or the restaurant owner page. And then we have an app sync that is configured with the Cognito that is used to run our mutation and queries from front end. And we also have some subscriptions. And then the app sync is basically sending data to the EventBridge directly. So up till now we have seen app sync sending data to the DynamoDB Lambda functions, but in this case it's not doing that. It is sending data directly to the EventBridge. And then on the other end of the EventBridge, that event that was sent by the app sync is being listened by a step function. And the step function has two Lambda functions inside it. One is saving the data or querying, saving or updating the data in the DynamoDB. And after that, another function runs that is actually responsible for sending these messages and emails, like sending my email and messages to the owner and the customers. So previously, we did not use this. Previously, when we were using AppSync, we did not use this event-driven architecture. We were directly connecting AppSync with the DynamoDB. But in this case, we're not doing that. We're sending event to the EventBridge. Now that event would have everything about the AppSync query AppSync mutation, like the name of the mutation and the parameters, and that would be passed on to this Lambda function. And then based on the name of the mutation and the and its parameters, we can create or update the data in the DynamoDB. And then this function would run that would send the email or the messages. Now, basically, when I was actually reviewing the code, there are quite a few problems in the code, and I'll mention them as I'll be discussing the code, and then I'll improve the code and upload it later. But there are quite a few problems. The code is not written very nicely, so it may be a bit hard for me to explain, but I'll try. Okay, so this is the simpler version of this diagram. So again, we have an app sync. All the mutations are sent to the EventBridge, and on the other hand, the EventBridge is invoking step function that has two Lambda functions inside. But you can see the queries. We're not sending queries to the EventBridge, and why is that? Because in queries we need some data, right? We need to display some data. When we run queries from front end, we need some data, like a list of orders or a list of bookings. We need to display that data. If I send queries to the EventBridge, then obviously EventBridge is not itself is not updating the data in DynamoDB, so I would not get the data that I need over here. So for queries, it's not best to send an event to the EventBridge. You have to do it directly with the DynamoDB source. Because if I send a query over here in the EventBridge, it would be meaningless, right? Because I actually need data of the query over here in the response of the app sync. So yeah, so we are only going to send mutations over here in the event-driven architecture. Now, a problem with this, a challenge with event-driven architecture is that we wouldn't be able to know that whether the mutation was successful or not in this Lambda function, because the response that this app would get would be coming from the EventBridge. Sorry, would be coming from the EventBridge, not from the DynamoDB that is inside the step function. So it would not be possible for us to figure out if the mutation was successful or not just based on the response of this app sync. We will need to implement something more over here that could update our front end that whether the mutation was successful or not. So this is one challenge that we have in an event-driven architecture. like this. Now, this is a very simple application. I wouldn't even suggest you to use an event-driven architecture in such a simple application, but it highlights all the important aspects of this architecture. And this is just the step function. What is inside the step function? So the first, inside the step function, we have two Lambda functions, and the first Lambda function is taking data from events that is coming from AppSync, events that are being generated by the AppSync to the event page, and doing operations in DynamoDB. So it would be like adding the booking, creating booking list, something like that. And then after that, it would be seeing if there are any emails to be sent or messages to be sent. Okay, so now let's move on to the code. So we have actually made the front end as well as back end. I have deployed the back just before the class. So first of all, I'm just going to show you how does it work. I'm going to configure the front end with back end so that you guys have a better idea. Then we'll go through the code. I'm just updating these the amplify file. We have already seen it. Now, because we're using Cognito and AppSync, we have to update the endpoint of the AppSync and the Cognito variables. Now let's run it. Okay, so
But you have to increase your resolution.
okay. First of all, let's make an account on the application. Let's run the application first. Let's make the restaurant owner first. So we're gonna sign up. Code. So you can see it's showing you the customer dashboard right now. That is the default page that you will see. But right now I want this account to be my the account of my restaurant owner. So to do that, you actually have to put in the. I'll go through the code after showing this, and you will understand it better then. You can see in our Cognito we have one user. Still loading the groups. We should also have an admin group. It's taking too long. Okay. Okay, you can see we have the admin group. Now all I have to do is add to group. So you have to do this manually because you can also do it using Lambda functions, but in this kind of application, I think it's best to do it manually because you will just have there will just be one admin and you will just have to do it once. So hit a group. Now I'm in the admin group. Now if I refresh my page, oh wait, I'll have to log in again. So you can see now it's showing me the admin dashboard. Now in the admin dashboard, I can actually write time slots that are available in my restaurant. So I can say 2 p.m., 3 p.m., that, and then 3. So this is the admin dashboard. Now let's make another account for a customer. So this is the customer dashboard, and you can see they can see the time slots that the admin entered. Now when I click on the book time slot, it will send the owner of the restaurant an email and as well as a SMS that this customer wants to book this time slot. Let's see what happens. So you can see it automatically got updated because we're running a subscription. So you can see it says already requested over here. And here it's saying that from 3 to 4 p.m. VAR is requested. And I should also receive an email. I did not enter my. Okay, so you should also be receiving an email and then SMS. Now, when I accept this booking request, the customer would get an email, or even if I reject it, if I accept it. So you can see today's booking. And anyways, how loading. So let me do the code. Okay, so here we go. You can see it has been booked, and we can still book this one. So let's go through the backend first. So the first thing that we've done is we have created a user pool because we need it for sign up and sign in, as I showed you. And you can see we also created a user pool client so that we can use this user pool on the front end using Amplify. Then that admin group that you were seeing over here in the the admin group, you usually not groups by default. The coordinator doesn't create any groups by default. You can see at the saying it to create a new group admins. We can put all our admins in that group. So that's why you could see an ad group over there. So this was our user pool. And then we created our AppSync API. That is the authorization type is user pool, referring to this user pool. So only people who are logged in from this user would be able to use this API. And after creating our AppSync API, so we have created this, we have created our AppSync API. Then we created a table. So this table is going to be used inside this Lambda function. So we have created Cognito, AppSync, and then the DynamoDB table that we use later inside the Lambda function. Now, now we're creating data source for AppSync. Now, as I told you before, our AppSync is either communicating with the EventBridge or with the DynamoDB data source. So for queries, we are going to go to the DynamoDB data source directly, but for mutations, we are using an event-driven architecture. So first, look at the query. Let's look at the query. So I'll skip this. Okay. So here we go. We're adding DynamoDB data source. We've seen this a lot of times, and we are passing our DynamoDB table over here that we created over here. And then let's first look at the resolver of this data source. So in resolver, we are saying query. So get time slot. So this really gives us all the time slots that you are seeing over here. All the time slots. And you can also see this in the over here. No, this is not the time slots. Okay. This is the query which returns all the time slots. So that's it. We just have one query in this application. Where was I? Okay. Now this was our first data source. That was for queries. Now let's look at the mutations. Now I told you that we're not directly adding mutations, connecting mutations with the DynamoDB data source, although we have been doing like that since the beginning of the bootcamp. Since the beginning of this AWS course. But now we want to send the data to the EventBridge directly. Now to do that, you don't add the DynamoDB data source, but instead you add an HTTP data source, and we have not seen this yet. So we have seen Lambda DB data source, and we have seen DynamoDB data source. We have also data source. I'll come to this later. Why do we have it over here? But this is the new thing, HTTP data source. So what this means is that the AppSync would send a request to an HTTP data source or an HTTP URL endpoint. Let's see how we configure it. First of all, we are passing the ID, and after ID, it is expecting a URL. Now to send data to the EventBridge, you have to send data to this URL. So this URL is events.yourregion.amazonws.com. Now this is how you access different services in AWS. I could have written a step function here as well, or some other service that should have worked as well. But this is how you actually communicate with the AWS services through URLs. So I'm saying I want to send a request on this URL, and then the name of the data source would be this. This would be this. This is not important. And then this is the authorization config. Now you cannot just send it over here and just expect a response. It has to be like authorized properly. Now this is also a very complex topic, but CDK makes it very easy for you. All you have to do is pass your region and the name of the service. That's it. That's all you need to know for now. So the service is events, and the region is this, and that's it. This is our HTTP data source. So we first created a DynamoDB data source that is used for queries. Now we created an HTTP data source. Now let's have a look at the resolver of this HTTP data source. And also we have the access of putting events to this data source. So it will need to actually put events on the bus. So we need to give access to it. Now let's have a look at the resolver of this data source. Now, just like DynamoDB data source, DynamoDB resolver, this also takes in request and mapping templates, and we have to write them in VTL, unfortunately. So this is the resolver. Yeah, okay, this is the resolver. So what we're doing over here is that we have made an array of all our mutations. You can see we have many mutations over here. And we're saying for each value in this array, create a resolver. Create a resolver on this HTTP data source. So for each of our mutations, create a resolver. And I'll get this part later. And then the type is mutation, and the field name is coming from this for each function. Like they would be passed one by one over here in the field name. So this is just like creating any other resolver. Now, what goes inside the request and mapping templates is very interesting. There's a lot of BTL over here. So basically, this thing over here is coming from another file that is in the utils folder. So this is the this is our request mapping template, and this is our response mapping template. So in the request mapping template, as I told you before, that we are sending a request to a endpoint. So we have to pass some headers and we have to pass support. Unlike in DynamoDB it was entirely different, because in that case we are communicating with the DynamoDB service. In this case, we are communicating with an endpoint. So the VDL for this is entirely different. So you can see the method is post. We're saying we want to send a post request. The source path is nothing. So if I had added something over here, this would have mean that I'm passing something over here. But right now, because I've left my resource path nothing, so it's going to be passed over here only. Now you usually add resource path if you want to send it to a particular resource in this service. So let's say if it was Lambda, and the name of my Lambda function was something, I would not write it over here. I would pass it in the resource, in the request mapping template. Yeah. But right now we don't need it. And then in the parameters, we have headers. So we write the content type header, right? This actually describes that what do you want to do with the service. And in this case, only interested in importing events from the AppSync to the EventBridge. So we're going to write AWS events.put events. So this is very important. And then in the body, this is what defines the structure of our event. That what is going to be sent from the AppSync to the EventBridge in the following event. This is what that is. And you can see in the detail type we are taking it from the parameter over here, and in the parameter, the parameters we are actually running that function over here. So in the first parameter, we are actually passing the name of the mutation. Sorry, the second parameter we're passing the name of the mutation. You can see we're running for each function, and each value is being passed one by one over here. So let's have a look at what that is over here. So basically in detail type, we are sending the name of our mutations. So the event that is going to be sent to the EventBridge would have a structure like this, and in the detail type, it would have the name of our mutation. And then we have in the source, we're writing event source, that is just a string that is saying it's coming from the application. Then event bus, we're going to keep it default. And in the detail, we're passing another parameter that is coming from here. And that is the first parameter. Okay, and in this parameter, we are actually going to pass the parameters of the AppSync. So every AppSync mutation has some parameters. So you can see we're saying if the mutation is time slot, then pass these parameters. Now they might seem weird to you because they're written in VTL, but we're saying basically you want to this is one parameter of a time slot. This is another one. And if it is add booking request, then we want to send these parameters. And if it's none of these and anything else, then we want to send these. And we're passing this variable over here. And that goes over here in the detail. So let me repeat this. In the detail type, we would be sending the name of our mutation. And in the detail type, we're sending the parameters. And then we also have a response mapping template. That is again coming from this file. We have just imported that file over here and running the function. So in the response mapping template, tell us that what would the AppSync return? Like when I will run this mutation, what would it return? In the request mapping template, we say that what would it do? So when I run this, let's say I run this mutation, it would send a request to this URL using this request mapping template. And in that request mapping template, we had this. And then this service would return something. So once you have sent a request, it would send us something back. And that is what we have to map in the response mapping template. And that is what we have done over here. So we are saying if we receive an error from the service, from EventBridge, then return that error, the message and the type of the error. But if the status code is 200, then return the result. So these are just variables of VTL. So this means that cdx.result.body means the body of the result. And if anything else is returned, then we are assuming to be an error. So we're just gonna append it to the error. So basically it is a bit counterintuitive, but the response of the app sync would be the response from the EventBridge. So this is how we have made our HTTP data source. Now there's one more data source left. This is a very interesting one. No data source. So one data source was the DynamoDB, the other one was EventBridge. Now there's a third as well, which is no data source. So no data source basically means that it is not adding data anywhere, not sending data to anything, not to any service, not to DynamoDB, not to Lambda function. It just takes, it doesn't send data to any other service, but it takes an input and gives an output. So the input would be the parameters that you pass to the mutation, and then through VTL you can actually add some static data to that input and then pass it as output. So this is the no data source, and let's have a look at the resolver. So it for the generation mutation. I think that the input we want the arguments, and the output would be just the result. So we're taking this and giving. You can also add some static data if you're good at VTL, but usually you just take an input and give it as output. Now, why do you actually need it? The question is that why do you actually need such a data source, no data source that takes an input and returns it as output? It's actually kind of hard to explain, but let me try. So as for that, so there are two use cases in my mind right now. So the one use case is that, as I told you before, that when you run a mutation from AppSync, the intent is to actually add data to the database, to the DynamoDB. Because you're using event-driven architecture, you are isolated from the DynamoDB. You are sending an event to the EventBridge, and you would only get response from the EventBridge. And later, what happens in the DynamoDB, you don't get to know in the AppSync. The AppSync doesn't get to know. Yeah. So what you can do is, in this Lambda function, you can run that no data source mutation that doesn't do anything. So basically, you can check that if we were able to successfully put the data in the DynamoDB, then you can run that no data source with the input parameter successful, and then you can run a subscription on that mutation on your front end, so that you would know on the front end that your data was successfully entered in the DynamoDB table. I'm not sure if I had been able to explain this properly. Let me repeat this again. It's kind of complicated. So let me repeat this again. So when you wait a minute. Yeah. Okay. So when you're adding data from AppSync, when you're sending a request from AppSync, in this case, it's going to the EventBridge, and the EventBridge is returning immediately something. It's not, and that response is not telling you whether the data was added in the DynamoDB or not, because that is our main intent. And there's no other way of knowing it, because it's happening after that, after we have received the response in the Lambda function. Now, the only way of knowing it is to somehow update update the status of this Lambda function to our front end. And the way to do that is to run a no data source. So let's first check that if the data was added successfully after the mutation ran, then you can run the subscription with the input successful, and it's going to return you successful in the output as well. And then you can have then you can run a subscription for that mutation on your front end, so that you can get updates on your front end that whether your data was added successfully or not. And you can do the same for fail. You can in the catch block, you can run this mutation with a fail input, and in your front end subscription, when the mutation would run in the front end, the subscription would give you that the addition of data in the DynamoDB failed. So this is the one case of using no data source. Another case is even more complicated. This is what we have used in this application. So as I told you before, that we have 2 pages on our client side. Okay, if you guys are getting it, because this is kind of advanced, and this no data source is not actually doing anything important in the functionality of the backend. So we have 2 pages on our client side. One is for admins, and one is for customers, as I showed you before. Let's say that in the customer page, I'm running 3 different mutations. I'm just making these up. Add booking request, booking mutation, and get booking mutation. This is just an example. Okay. So let's say I'm running 3 mutations over here in my customers page. And what I want to do on the admin page is that I want to run subscriptions on all these 3 mutations. Now, if all these 3 mutations have the same response type, then you can put them in the same subscription. You just have to run one subscription and you can check for the changes in all 3 on all 3 mutations if their response type is same. But if their response type is different, like this is returning something else, a different data structure, this is returning a different data structure, then you would have to create different subscriptions for each one of them. Now the problem is that if you have to run subscriptions on them, given that they have different data structures, you would actually have to run 3 different subscriptions. So subscription request, patient, subscription for this one. This is now you would have 3 subscriptions running on the admin page, and let's say if there were like 10 different things that you want, different subscriptions running over here. Now a trick to reduce the number of subscriptions is to actually run your no database mutation. But I'll try to explain it to you. It's kind of hard to explain it like this, but I'll try. So what you can do is, after running each of these mutations on which you want to run subscription on another page, you can pass the output of this mutation to the no database mutation. Does is that it takes the input and returns it as output, the same output. So you can do it every time you run a mutation. For every mutation, you run the no database mutation, and you pass the output of your main mutation as an input to your no database mutation, and then on your admin page, all you have to do is run subscription on no database. So this would actually save your resources. Now, because running this mutation is not expensive at all, because it's not adding anything to database, doing nothing. It is just a way of updating your status. So now we have actually converted 3 subscriptions to just 1 subscription over here. So I'm not sure if everyone got this or not, but I know it can be a bit tricky to understand, but you will understand it if you do it yourself. So I've converted 3 different subscriptions to just 1 over here. So you can actually save resources, because the time limit which you're connected to your subscription, I think you're actually getting charged for it. So if you have like 100 subscriptions, not 100, maybe 20 subscriptions, then this would be a cheaper way to go. And I think this is why we have used a node data source in this application. I'm not exactly sure, because I did not went through the front end, but yeah, I think this is why we've used it. So this was our node data source, and we have seen all the resolvers. Now we have covered up till here from AppSync to EventBridge. Now let's have a look at the step functions. Okay, and then we have created an SNS topic, because I told you before that we are sending messages and SMS. So for that you need a SNS topic. So the messages that are being sent to the owner are being sent through SNS, but the messages being sent to the customers are being sent through SES. You don't have to use 2 different services, but we have just used it over here, just to show you how to use them. So we have created an SNS topic, and
Varis, are you there? I think you hung up. Let me call you. Varis will be back in a second. He got disconnected.
Hello.
Hello.
Can you?
Yes,
Yeah.
I can.
Okay. Yeah. Sorry, I got disconnected.
No, no problem.
Okay. So we have created a topic. We'll be sending. As I told you before, we will be sending email and messages. So we are sending emails to the owner using SNS, but we're sending emails to the customers using SES. You don't have to use different services. We have just used over here just to show you guys how to use them. But you can just use one service to send emails to anyone. And then over here we have created an input parameter. Now this is something new. I don't think we have discussed this before. So this basically allows you to create a parameter that you can input from your terminal from over here. So when you will be writing CDK deploy, you can pass parameters with it. So you see over here, when I ran the CDK deploy command, I actually wrote dash dash parameters. Let me zoom it in. You can see I wrote dash dash parameters, and then I wrote the name of the parameter and then pass my parameter. So I pass my email. So I create a parameter for email so that I can. So these parameters for the owner, email of the owner, or the name, and then the phone number of the address. So I've created two parameters that you can pass from the terminal. And this command is actually there in the documentation of the step. You can copy paste it from over there. So we write dash dash parameters and the name of the parameter and then pass the parameter. So one parameter is for email and one is for phone. And then we're also creating subscription for that email that we're getting from the parameter. So that parameter would be saved in this variable. And then we're creating a subscription on it on our SNS topic. And same goes for the phone number. We're creating a SMS subscription. And now comes the step functions. Um, so as I told you before, we just have two lambda functions inside our step functions. So first we create our first lambda function. So this will be taking care of the DynamoDB operations. This one. So events would do EventBridge. EventBridge would send those events to step function. Step function would pass that to the function first. So this function would have access to all the would have access to the name of the mutation and all its parameters. And here we are doing all the adding and updating entries in the DynamoDB, and then just giving access of the table to this lambda function because it would have to write in the table. And then these are just roles, policies now because we would be sending messages. We just have to give some permissions. We have seen this a lot of times. So basically, we have just created one lambda function now, and now we are going to create the second one. Now this lambda function is this one that will be responsible for sending the messages and emails. As we have discussed step function in great detail. So we know that we need to create steps to put them we need to create steps of lambda functions to put them in a step function. So you can see we have created a step. We have called it first step, and we have referenced our first lambda function over here. Then we have created a second step for our second lambda function over here. We have passed lambda function over here, and then we define the chain, the sequence in which they would be executed. So we're saying we want to run the first step first, which is the DynamoDB lambda function, this one that is going to update the DynamoDB, and then the second one that is going to send the emails, and then we make it a state machine. So this is basically our step function. So we pass the chain in the state machine, and that's it. Now we have made our step function. Now we need to define a rule on which events does it need, which events would invoke this step function from the event. We have not done that yet. Now to do that, you define a rule, and the rule is saying that if the event source is this, which is exactly the same that you pass in the request mapping template, As I told you before, these are the events that would be sent from the app sync to the EventBridge. So we need to match these with our rule. So the event source is the same thing over here. This name, this is what we have passed over here. And in the detail type, I told you that we are passing the name of the mutations over here. Oh, sorry. Yeah, so we are saying if in the detail type, if any one of these mutations that the array that we made, if any one of these mutations are there in the detail type, then we are good to go. This event should invoke our step function. And in the target, we gave our step function, state machine. And that's it. So this is our architecture. Now, what's left is the inside of Lambda functions. The first one. So I'm going to go through it quickly because it's just a basic DynamoDB functions, DynamoDB operations, like adding and updating data. So you can see now in the end of this Lambda function, now because step function would receive an event from EventBridge, and it would pass that as an input to the first Lambda function, and by input I think to the event of the Lambda function. So you can see we can actually check for the name of the mutation. So, and I told you that the name of our mutation is coming, what? It's coming in the detail type of the event. So we're checking in the, sorry. So you can see in the detail type, we're checking for the name of the mutation. And based on that, we are performing operations in the DynamoDB. So in this case, we are putting data somewhere, we might be updating it. That's not really important. But yeah, it's important to understand that how are we actually getting this input. We're getting it in the form of an event. So again, we're checking for the name of the mutation. Yeah. So this is how you run your mutations. And this is just the code to update or data to the DynamoDB. So I'm not going to go through it. Now, what's important is that whatever this function returns gets passed on to the SNS topic. Now, this is where the problem is in the code. Now, as I told you before that, we don't want to send email every time, email and SMS on every mutation. We don't, right? We don't want to do it. But the problem with this architecture is that this function would run every time this function runs. This is the problem. Even if you don't do anything inside it, it will still run because it's in the step function. So let's say that if I just want to run, what do you call it? Let me actually have a look over here. So let's say if I just want to run a delete booking request that is not supposed to send any message to the owner or the customer, it will still run this SNS topic. This is a problem in the code. Now to fix that, you actually have to add some more logic to the step function to actually first filter out the output of the first Lambda function, and if it contains like a message that needs to be sent, only then send it to the SNS topic. Only then invoke this function. Right now, what we're doing is that if I can show you the code of the SNS handler, this function, what we're doing over here is that we're just checking if that email or the message is there or not, and then we are sending the messages. But even if there's nothing over here, like even if we don't have the customer email, then this if block would not run. We would not send any email. Even if there, as soon as even this block and no matter send to the owner, this function would. This is the problem. We have not stopped this function from running, even when there's no data to send, even when there is no email to send. This is the problem over here. So I'll show you how to fix it, but let me first just go through this code. So basically this Lambda function I'm talking about, this will receive the output from the previous Lambda function. So we are saying that if previous Lambda functions returns a customer email, this means that previous Lambda function wants us to send an email to this customer, then send this email. We just created a parameter. We just created a params variable that has everything I think we have already discussed this before in the SES lecture. I don't have to, and it's not even important. We're just sending an email. And same goes for the other block. This block is for sending message to the owner and a message as well. So here we're using SNS. But the important point is that this function would run even if both of these ifs are false. Like even if you don't go into these if blocks, and we will just be like wasting our resources running this function for no reason. The ideal case would be to check the output of this function first within the step function, and if there is something to be sent, only then run this other function. Otherwise, don't run it. Now to do that, we can actually go to our step functions. Because even I don't remember how to do it. It's been a long time. So here we go. So you can see we have a choice step as well in the step function. So we can use that. So what it does is it actually checks. I think choice function actually checks the previous output, and then based on that output, it can actually make the next move. So we can say that, okay, if the email is present over here, only then invoke the next function. Otherwise, just end the step function. So let's copy some code from over here. So this is the choice step. Okay. So I'm going to create a new step over here. First step. And we also need to create a success step. And why is that? Let me tell you. Now, so this is our first Lambda function, and here we want to check. So this is our first Lambda function. This one over here. We're gonna pass the output. Sorry. So the output of this Lambda function would be passed on to our choice step that we just made, and the choice is gonna see there's something in the output that needs to be. The output says that we send an email, then run our second Lambda function, this one. Otherwise, run the success step. And I told you in the step functions lecture, the success step does nothing. It just terminates the step function with this status that this step function has been successful and just ends it. So we can. So this is a very good solution for this problem. So let's do this. So I've actually made a success step. So we are saying that if the payload. So let's see what's being returned in the payload. So if this is present, then we need to run this Lambda function. So I'm going to say that if payload if this is true, then I have to run my second step. So I'm saying that if so basically I'm saying that if something needs to be emailed, then run my Lambda function, my SNS Lambda function. This is the condition that I just made. Now I'm going to write the other condition that if nothing needs to be sent, then just run the success state, and that would just terminate our step function without running this Lambda function. Now there are also some other variables that need to be checked over here because I'm sending some variables over here as well. So I'm not going to deploy it for now, but this is how you will do it. So you will put a condition for all the variables, and then on the other branch, you would check if this is false, then I'm going to run my success step. So if I can. This is what I've done. So this step basically takes input from the DynamoDB. So whatever DynamoDB returns becomes the input for this choice step, and it checks that if this variable is there or not. If it's there, that means that I need to send an email. So it moves on to this function. If it's not there, so it goes to success step and it says that okay, terminate this step function. We are done, and the step function was successful. So this is what you can do. Obviously, I've not named the variables properly. I'll have to double check them, but this is how you will do it. And I think that's it for the backend. There's not much to explain in the front end. It's just calling queries and mutations and subscriptions. And I think we have covered that in the beginning of the AWS lectures. So yeah, I think that's pretty much it for today.
Harish, you have done a marvelous job, but I assume that you must be tired.
Yeah, I'm very tired.
Because focusing on the code is a very tough. It requires a lot of brain cells.
Yeah. Especially if you've not written it yourself.
Especially.
Yeah.
And now what you're going to do is go and maybe sleep or maybe have a nice dinner. Thank you so much, everybody.
Thank you. Okay.
Your effort will be has been recorded on video for posterity. Thank you so much.
Okay. Thank you. Bye-bye.